All right, let's get started on time. This workshop is being recorded, so that you know. I think you were informed of that when you registered, but it's good to get reminded of it. And so, welcome everyone. First, I want to say that I'm joining today from the beautiful west coast of North America in Vancouver, on the unceded territories of the Coast Salish people. I am here today with Paul Triana, who is going to present with me. Paul, do you want to say hello?
Hi, everyone. Welcome to this workshop.
And with us today as well from the Metacreation Lab, we have Arshia Soban, who is helping facilitating this series of workshop. Arshia, are you still here?
I'm still here. Hi, everyone.
Awesome. So let's get started. That's the first workshop of a new online workshop series that we are willing to offer every year at the Metacreation Lab. And so we have 2 hours together, roughly. Depending on how much Q&A there are and how good we do with the presentations. And it's going to be an opportunity to present to you a number of work and thoughts that we have put into using AI for music making. And eventually, Paul will serve you the main course, which would be a demonstration and introduction to our Reaper MIDI-GPT plugin. So as I was saying, this is a series of workshops on open source creative AI tools. And we feel that it was necessary, and we tried to communicate and disseminate around those tools because a lot of the world, most of the world, is being served a discourse around AI that is really dominated by the corporate discourse relayed by the mass media, and that is basically selling AI as being made of big data that require extreme amount of compute using stolen data with the discourse potentially of those AI being impossible to stop, and then we'll eventually replace everyone. So against this dystopian framework, a lot of people are disturbed, and I think I am myself too. And at the Metacreation Lab, we are one of the examples, there's many others, of the diversity that exists in AI, whereby one doesn't have to subscribe to this vision that is being dominant in the media, and there's alternatives. And so throughout those 4 workshops, we're going to present some of those alternatives. Today, we're going to talk about computer-assisted composition using MIDI-GPT, which is our homemade MIDI generation model. Tomorrow, there'll be a workshop around our Autolium visual synthesizer, which is a tool that allows to train your own model on your own data without relying to the cloud and to supercomputers and data centers, and without using anyone else's data, which a lot of artists feel more comfortable with. And then on Friday, we will have the Fragmenta workshop, which will be given by Misag Azimi, that joined us for a few months here at the Metacreation Lab. He's been working on interfacing Stable Audio 3, which is a clean audio generation model, and again, allowing musicians and composers to train their own LoRa's to personalize models on their own material and then use that system. And then we finish this series of workshops on day 4 with a workshop on model bending of diffusion models in Comfy UI. And so that would be where the series will be made of. And I'm admitting more people that were in the waiting room. Now, before I get started, really, I want to emphasize that AI is a bit of a misnomer and can mean very many things. And when we talk about AI at the Metacreation Lab, we don't talk about sentient machines that are going to take over the world because we don't really know how to make these, but we talk about systems that are usually trained to achieve a specific task. And in that sense, AI is nothing new. It's ubiquitous. It's already there. It's already deciding which road you take from A to B when you look at the Google map, etc., etc. And at the Metacreation Lab, we've been interested in creative AI. And so creative AI as a professor, I can't resist but to define it, is this idea of partially or completing tasks, which is what AI does in general, but here creative tasks. And so creative tasks are interesting because there's those tasks for which there's a lot of subjective elements. And we find them in many, many different domains. So at the Metacreation Lab, we're really looking at the science of the automation of those tasks, artistic practice regarding generative systems around those tasks, and we design applications with the industry and on our own. And today, we're going to present some of those systems to you, cumulating with MIDI-GPT and its use in Reaper. We're in the middle of a wave really of a rise of AI that was already very, very present often as a system for recommendation. If you think of the internet and Google and others, is you actually enter a prompt, you make a search, and it recommends to you some content. Spotify recommends to you the music to listen to, and Netflix what to watch. And we've been moving in the last few years, 5 or 6 years, towards content, not just recommendation, which continues, but also content generation. In fact, now when you search the internet, some search engine would give you an AI-generated answer before they recommend you any content. And so there's really a transition here that is ongoing. And part of that transition is also affecting creative domains. And that's why we see as well the rise of computer-assisted creativity and computer-assisted creativity tools. It mostly started and became really, really popular with computer-assisted graphics around 2020 to 2022. A lot of prompt-based systems appeared that allowed to very easily generate content. For example, I was giving in March another workshop on Autolium, and I asked at Simon Fraser University, we use Microsoft 360. I am not a fan of Microsoft, and I'm not happy about that choice, but that's how it is. And I could ask back then the AI system, embedded AI system, to generate a poster for that workshop, and it did generate this particular poster with this prompt using those models. And I redid the exercise this morning, actually, preparing for this workshop. And because everything has changed, the models underlying and things, I get something completely different, which is interesting, but also with a lot of really good elements, but also some errors and some hallucinations, like the logo of the Metacreation Lab is not right, and things like that. And so that's really what became popular, is this idea of prompting. And then there's been some pushback quite a bit, because when you do prompting, you can go only so far when you have really a vision. Here, if I now want to change and correct the Metacreation Lab logo, I probably would need to do it manually, because I'm going to have to fight the AI to do it, and it's going to be really, really hard to get there. That's what we call the last mile problem. When you do prompting, there's a significant gap typically between what you will get, which is almost what you would want, and what you actually need for production ready, something that delivers consistent, reliable business value. And so while those big AI systems are sold as being omnipotent, the truth is that prompting is not a really great and flexible way to navigate such a big system. And so we've been looking at alternatives, and we'll talk about them today with MIDI-GPT and throughout the workshops with other tools. It was in 2020, 2022, so that very, very new, this idea of prompting. But the truth is that it was not that new, because at the Metacreation Lab and elsewhere, to be honest, back in here quite a while, back here, it was papers from 2012, and we were already designing systems for prompting. And here I present this system to you because it's actually quite relevant to the workshop today. It's an early example of computer-assisted creativity system, but this time for sound design or soundscape composition. You enter a prompt, a description made of keywords of what you want to hear, a duration, and then you get to draw two curves. A curve for the valence, how positive or negative that soundscape is going to sound, and a curve for the arousal, how calm If the arousal is low or eventful, it's gonna be. And then the system is gonna retrieve sounds. Here, each little red box is a wave sound, and it's gonna put together, as you would do in composition, uh, with a wave file, a timeline here with different tracks, 4 different tracks, and put those sounds together, and then in the background automate a mix, and you can download that timeline with all those sounds and edit it in Reaper, or you can render directly the results. So the system is called Audio Metaphor, and that's an early example of a prompt-based computer-assisted creativity system in 2012. And in fact, this idea of 10 years before the market, what we were doing in the lab is often about that, about a decade before you actually hear about those type of systems. So it's nothing new. So we had a little bit of time to study this system of prompting. If I want to demo to you Audio Metaphor, here I have some examples. I can ask for a waterfall in Thailand, and then it might sound like this. So it's a little bit heavy. And in fact, with those type of system, what's interesting is you have a back and forth. So that's the idea of computer-assisted creativity. Often the interaction is turn-taking. You have a back and forth where you make a request, you get a result, you modify the request, get another result, or regenerate from that initial request and get a different result, because those systems are typically non-deterministic. And then you're supposed to navigate that way towards what you want. In this case, you also might want to be able to edit and modify what you do with Audio Metaphor, and because it's not perfect, but it does a lot of the work that is often the painful part for a sound designer, which is to search through vast quantities of sounds and recordings and find the sounds that are relevant for a particular scene. And here, for example, those sounds here are also classified into background and foreground sounds. And so you can edit that timeline and pick and choose and get the sound that you like. If you want to ask the system to generate the soundscape of a city in the bush, it might sound like this. All right. And then, of course, often when you give to artists those type of systems, they use it in creative ways. And so here you can go abstract. Often artists try to break systems and find their own ways to use those systems, use or misuse those systems, depending on the type of artists and creators we're looking at. So here you can ask for something more abstract, like a quenching rain drench my burning head, and it's hard to imagine what it will sound like. But it will sound possibly like this. All right. And so I encourage you, it's online, to try Audio Metaphor for yourself, if you wish, at audiometaphor.ca. That's an early example of computer-assisted composition system in the audio realm. Some artists have been using it. And there's examples on the website as well, and it's collaboration with many people throughout the years, and led by Mike Thorogood, who is now at UBC Okanagan. So prompt-based computational creativity was not just on the rise for visual generation, but also for music generation. And I suspect that most people in this room would already know and have heard about Udio and Suno and those type of systems, which allow very easily to generate pretty incredible in terms of quality, diversity, believability, if you wish, musical content based on simple prompt. Here, for example, is something that I generated for a previous talk as an example. Etc., etc. And of course, you can, if you don't like it, you go back and forth and you can get something much more precise. And then you might say, yes, but this is all fed on, this is all averaging machines, and it's all fed on pop or Hollywood-based content, and I do experimental music, and I can't do that type of thing. Then you would be wrong, because if I ask for something more abstract and electroacoustic here with panim and dynamic, it's going to do something potentially good. All right. And so therefore, because the systems are so convincing in their work, there's been quite a bit of pushback by the industry, major record label, a lot of artists, and also stakeholders, the people managing or making the money for and with the artist, did push back quite a bit. And there's ongoing legal battle. Some of them have settled already regarding the argument of whether it's okay to train AI on things scrapped from the internet under fair deal or fair use. At the Metacreation Lab, we use fair deal or fair use to justify a lot of our work, because as researchers in Canada, we actually can use data that way. But because of those AI systems and their generalization, there's been a real rise of synthetic content. In fact, when it comes to text, we're already at the moment where AI-generated content online is matching the amount of human-generated content. And it's predicted to be similar for most media. And in fact, there's already a flood in the case of music of AI slop, as some call it, but some of that AI slop is actually in the top 40 and in the charts. And so there's really a wide variety of AI-generated content and a massive quantity of it. And so with the rise of those prompt-based systems, I just showed you audio metaphor. We can, and we do a lot of that at the Metacreation Lab, evaluate those systems. And what we find is, indeed, the promise of those generative systems is to lower the barrier of entry for beginners, because with audio metaphor, if I'm not a sound designer, I can do things that I wouldn't be able to do otherwise. And if I'm a professional, to try more things and go more in breadth and eventually work better and faster. And when we, through our studies, here this is one that was published last year of audio metaphor, we actually show that those statements that I just made are the case. You go faster and you produce better outcome with AI than without AI. But with the caveat, and that's an important one, an important but, with the caveat that with prompting, you don't necessarily feel like you're the author of what comes out. When I showed you the posters generated earlier, I feel I asked the system to generate those posters, but these are not mine. I mean, I'm not the author. And so when it comes to artistic expression, prompting is also problematic when it comes to authenticity and authorship. And so the picture, and this is another AI-generated poster, is of course more complex, but it's true that prompting alone can create a more random output, and then you become a curator, and there's no real ownership. While, of course, you can also prompt in a much more rich and complex way, in a way where you can argue that there's authorship there. So it's not just about what AI you use, but it's really about how you use it and how much work you put into it. And then eventually you can gain control with prompting as well. But what's important to know is that often in most countries, including Canada and the USA, for example, simple prompting will not grant you authorship or copyright ownership over the generated output. And so even in the context of this workshop, it's important to have those things in mind when we choose as creators the type of tools we're going to work with. All right, so that was my long introduction, but some important context, I think, not just for this workshop, but for the series as well. So now let's get into computer-assisted composition. This is nothing new. In fact, computer-assisted composition or algorithmically assisted composition was started before computers. A very early example of sort of systematic rule-based generative system for music is that of Guido d'Arezzo, which is one of the inventor of musical notation as well. And he was working on a generative system, and the algorithm didn't need a computer. You could do it manually. And the idea is that for each vowel of a particular text, he would associate with a rule a particular note. And so each text would therefore generate a particular melody. And you can see here a very early example of conceptual machine that is a generative music machine. And we're talking 1,000 years ago. Actually, this is the 1,000-year birthday of that piece this year. So nothing really new. And then there's a long history of from early automatons to a more sophisticated one of the development of those either automatic music playing machines and sometimes automatic music generation machines. And so I won't go here through the history or do a survey because we want to focus on the tools themselves. But this is nothing new. And when it comes to computer-assisted composition, the first recognized piece actually composed using an algorithm, a Markov chain in this case, in a computer was in the 1950s, 1957. The ELIAC suite is sort of widely recognized as being an early example there. Created by composer Leon Hiller and the mathematician Leonard Isaacson. And the piece was using at the time, a mainframe computer at the University of Illinois, Urbana-Champaign. Urbana-Champaign, yeah. And then you see a long history of well-known systems until today. I won't do a full survey of the field. There's actually way too much, interestingly, but if you want to know more about it, we published this year, so it's a fresh material, a survey with Dr. Renaud Bougan-Chemebe about computer-assisted composition. And the survey also has a typology, because if you think about computer-assisted composition, there's all sorts of composition tasks, from generating full pieces to generating motif, arrangements, or orchestration, the interpretation of a piece, velocity, micro-timing, all sorts of melody composition, harmonization, all sorts of tasks, all sorts of data representation, all sorts of algorithm you can use, all sorts of interfaces you can give to creators to interact with those algorithms, etc., etc. In fact, as part of the survey and the state of the art, we looked and we identified over 130 different systems that you could use and learn now to use some sort of AI to help you in composition tasks. So here and for the rest of this talk, what we mean by composition is just symbolic music notation. We're not going to look at the interpretation of a composition. So you have a composition, which is to make a musical form, and you then eventually can play that musical form. So you make a score and then you play that score. The playing would be the interpretation, and the making of the musical score would be the composition. Sometimes when you improvise, for example, you in a way make the composition and interpret it at the same time, in real time in this case. But here we're going to be interested at composition. And then when you do computer-assisted composition, you can still render directly things in audio outputs, or you can really generate a symbolic notation of the music, whether it's a score, or here today we're going to talk about MIDI. And here are examples in this slide of some of the 130 systems that we found. And you will see here the commercial one have a minus in front of them. The one coming from research and open source have a star. And the one with F are free and available. And today I presented already to you Audio Metaphor, which is one of the first audio-based one. And then on Friday, we will be presenting Fragmenta. Misag will be presenting to you Fragmenta. But today we're going to focus on the MIDI-GPT-based system. But while we do so, I want to note that there's plenty other MIDI generation systems that are out there, and so we're not going to get a full survey today. We're just going to narrow down on MIDI-GPT. And with that, I'll transition to a little introduction of MIDI. I suspect most of you, I know some of you, and I can tell, and I know that you know MIDI well, so I won't spend a lot of time, but for the sake of the recording of this video being complete and this content accessible, I'll say a few words on it. So MIDI is one way to represent music in a symbolic fashion. It's really made, it was a standard for communication between early digital musical instruments, and it's ready made to be to be a computer representation of musical composition and a little bit of interpretation, in the sense that, unlike on a written score, with MIDI you can precisely indicate the velocity of notes. You can indicate micro timing, deviation to the actual beat, and you can actually, with musical instruments like the one on the right here, play the MIDI parts. So you can both compose and interpret, but here we're going to focus on composition today. All right. And then a MIDI, the main element of MIDI that we're interested in here will be MIDI notes when it comes to composition. And MIDI notes are corresponding to pitches that themselves are corresponding indeed to frequency of fundamental frequencies of those notes as perceived by our ears. And there's typical MIDI events. So it's an event-based architecture, and you get notes on. So you start a note off. And basically the duration of the note is the time between the note on and the note off. And then you indicate the pitch. And here in MIDI, there's 128 pitches, which correspond to the key of a standard keyboards. And each note has a certain velocity, which indicates its dynamic and how hard or fast the key was struck in the case of a keyboard, otherwise some sense of volume. There's also all sorts of different MIDI standards and in terms of encoding, plenty of subtlety that, of course, I won't talk about here and today, but we can get into that later. And then there's all sorts of MIDI messages that can be sent for all sorts of expressive dimensions like sustain and pitch bend and modulation, which are useful for some instruments. Often, MIDI scores, if you wish, are visualized using piano roll visualizations. And then in MIDI, you got program numbers that encode instruments, which typically also correspond to. So you choose a program number for a given MIDI channel. And there's 128 of them. It's always powers of 2 because memory was, and those encoding were compact and memory was scarce back then. And they're grouped by groups of 8. And you can see here the full list from 0 to 127, the full list of one of the standards, but the main one is called General MIDI. And this is an example of a piano roll, and we'll see them concretely when Paul will demo it. We'll see all of that in Reaper. And you can see 6 different instruments, different programs, and then for each a piano roll of that particular track on a timeline. Okay, so I was talking about prompting earlier on and its limitation. And so when we think about alternative to prompting, first music is a really good candidate because if we could say with word what we do with music, we probably would stop doing it with music. There's really something irreducible in the musical content. And so from very early on, a lot of the interface, this is a collaboration with my colleague Arne Engelfeld for generating chord progressions, and I think the patch is still available online. Here, for example, you feed music, and then you make requests using using musical gestures, which can be curves that you draw, and then you get output that way. So there's alternative to very early on to the text prompting. And then you get those compositions and you can work with them, interact with them, and refine them, and eventually you can get them interpreted. Often, MIDI interpretation is not giving you musically very satisfying results. It's hard to make MIDI sound good, but if you extract a score and you ask humans to play it, then it might sound like this, which is an example from Dr. James Maxwell, who was with us 15 years ago working on computer-assisted composition. And here this is a piece that he realized with his system MANUScore at the time, interpreted by the Yelton String Quartet. All right. I like those little musical intermission here. It's like taking a little breath. So yeah, that in a way, computer-assisted composition in MIDI, for example, is nothing new. But then there's deep learning. And so the model we're going to present to you today, the different breed, because they're much, much more powerful and much, much more accessible and easy to operate than the one we had. And for those models, even in deep learning, because we're interested in systems that aren't running on big data centers and aren't necessarily hosted in the cloud, but run on your computer because musicians have studios and they like things to run locally, then MIDI is compact enough to really allow to do really, really high quality models and run them locally on a small computer. So the whole adventure started with MMM, a series of multi-track music models that we developed with Dr. Jeff Hans back in 2019. 2019 is the year where GPT-2 came out, 1.5 billion parameters, for those who remember. And we thought, oh, let's use the same architecture, GPT-2, and train a model for music. And so we did. And it turns out that still to these days, it's one of the most versatile and good model out there. And we've been building on it since with a quite large team of collaborators. And Paul is the latest in a way in that lineage, and is now maintaining the repo to the models, and the models have been renamed MIDI-GPT. And the multi-track model in this, because they can generate the 128 MIDI instruments. They know all of the MIDI instruments, and they cover all musical genders, at least all of the one covered in the dataset. And we talk about that and the bias that those models necessarily have later on. And it's been trained on all sorts of music with all sorts of keys and time signatures, etc. So it's quite versatile that way. And the two ingredients, as often with deep learning, that makes this model quite successful and musically savvy, is the dataset. We have a big dataset which has been released and published about both in conferences and in journals. And that's where we used our fair data, the use of fair deal for research in Canada. We scrapped everything that is not behind a paywall that is MIDI files. And that resulted into, at the moment, around 2.4 million MIDI files. We keep on finding some. And that's released at GigaMIDI. It's on Hugging Face. If you're interested, there's thousands of downloads, and you have to sign something to download it proper. And what I want to say is this is a data set that is available for research and not for commercial use. And so when we work with the industry, we typically don't release the model that we work with them on. However, because that's an important limitation, we're working hard with legal assistance, with the Copyright Office at SFU, and with Key-Only and other researchers on trying to extract a subset of GigaMIDI that could be more clear about the different licenses that are associated with different part of the data set. And what would be really nice is to be able to release a public domain Creative Commons data set. In other words, a clean data set that we could train model on that could potentially be commercially used. Of that composers like you and I or musicians in general would feel okay to use, because it's for sure that no copyrighted material or stolen data is part of those data sets. A lot of music is in the public domain, classical music, for example, and lots of music for all sorts of traditions are coming from far enough that there's no problem. And so we're working hard on trying to distill from what we got for research, things that can actually be used outside of research. But with that, those models trained on public domain and CCO are in the making, and they should be released in a few weeks. So this workshop is a little bit ahead of time here. I would have liked to give it when we're fully ready with commercially ready models, but we're getting there soon. So I wanted to mention that today. So the first ingredient of a successful model is the data. And then with all the bias associated with those data, because in MIDI you can't encode all of the music. There's non-Western music that don't even fit in this paradigm of having 128 pitches, and you can't really encode those traditions, for example. So it is discriminatory by definition, like any sort of encoding or representation that is fixed that way. And the second ingredient, beside the data that make the model successful, is tokenization. So the tokenization of MIDI-GPT is an interesting one that really encodes the hierarchical nature of music, whereby a piece of music is made of several tracks, that is made of, and each track is made of bars, and then you have different control. And with that tokenization, you can do very interesting infilling. Infilling in this idea of filling the blank. And I'll play this little video here that gives examples, and you see that today in Reaper how we use the model. So here there's no prompt. So we move away from linguistic prompt, but there is in fact a prompt because it's a GPT. So it's an autoregressive model that can only continue sequences. But the prompt is the music. And so you give it music and it makes more music. And so I'll play some examples here and then go into more detail after that. All right. All right, so that's those are examples of infilling, and that's really what you're gonna learn today with MIDI GPT. That was like a little demo online, but today we'll work in Reaper. And so what that allows to do with this model in a way is that you can prompt it with existing music. Let's say you made a chord progression, and you made a melody, and now you want a rhythmic track. Then you set the instruments you want, and it will generate all of those bars, conditions on the bars that are above. You can also say, hey, I don't like it, make me another one. Or I can say, hey, this melody, like, I don't like, please resample it. And it will erase it and it will regenerate it based on the context. You can also select particular bars, just I like everything, but change this particular bar or change this set of bars and then resample them. And typically, you can also force the system, of course, to come up with content that is different from the content that was there before. Sometimes the constraints of what's before, what's after, what's under, and what's below are so strong that there's not that many possibilities that make sense given the data, and therefore the system is going to regenerate what was there, especially if you have repetition. Let's say you have a repetitive instrument, something that is looping, while you erase some of it and you ask the system to regenerate, he's looking at the context and he's like, well, we're in a loop here. I'm going to do the same thing. But if on the reverse, you want to do a variation, then you can force the system to do something new and different. You can change the temperature of the sampling. You can introduce more entropy, get something more typical or something less typical. The system has only a certain context that it can see in terms of number of nodes, which are then expressed in token because the network sees tokens, not nodes. And so it doesn't have an amazing awareness of long context. And so, for example, right now, it doesn't really deal with structural forms such as introduction, middle, conclusion. But locally, it works very, very well. So that's the idea of infilling. And apart from infilling, we also introduce all sorts of controls. And we're going to release a set of models. There's already a few out. Paul will talk to you about these with controls, and there's a long list of controls we are working on. But here, for example, you saw in the little video control of density. Or I want, this drum track to be more dense or less dense. Or I want this particular bar to be more dense than the other bars in the drum because I want something. And so we can control pretty much everything, like a lot of things in these slides, key signatures, forbidden notes, note density, note duration. I want very low density with long durations that give textures very different from like short duration and high density. I want to control polyphony. This track is hooked up to my analog synthesizers. I have only 3 voices, 3 oscillators. Don't give me 4 voices of music. And then we can control the style and all sorts of also high-level parameters. We're working on controlling valence, arousal, musical tension. And then in research, we're working on controlling velocity and microtiming, but we won't talk about that today. So here is another example of the system, a predecessor, but this is the same, the multi-track music machine at work with some examples of infilling. And the use of control, I think density is demonstrated here. All right, I was finishing with an example of bar because in computer music research, you have to generate some bar to be credible. If you want to test that system, there's a link that Lou just posted in the chat, but that's really from the beginning, from 2020. More recent and more complete that you can stream the MIDI directly to your DAW is the online interface called Calliope, developed with a group but led by Renaud Bougen-Chenebe. And using this QR code, you can access it. With Calliope, you can really do everything that we talked about so far. And that's an online web interface, and so you don't have to install anything. You just have to create an account. One of the things that can be used here is to take existing music that is in the public domain. I mean, you can also, if you're copyleft and you don't believe in copyright, take whatever you want. And the status of MIDI files is complex, right? Because you can't really copyright a sequence of chords or a sequence of notes proper. Often what's copyrighted is the interpretation, the audio out of it. Although the score as an object and as a piece of paper is also copyrightable. So it's complicated. So do whatever you want, but at your own risk. In our case, I wouldn't personally use copyrighted material in my things, but there's a lot of things in the public domain. Here, an example is using Calliope to make a variation, an original piece, but based on resampling a random number of bars, all the bars, but in a random order of an existing Mozart piece, and then augmenting it with other tracks that could not have existed when Mozart was around. So here is the system at work. That's actual Mozart. Adding a guitar and a vibraphone. An electric bass. So here, going back and forth, starting with your own material, working with the system, or making variations of existing material like that, you can get to compose things that you might not have composed otherwise if you're a beginner. And if you're a professional, it might give you ideas and make you go faster. We'll look at some of the results we got when we do research. So that's the second system here, Calliope. In Calliope, you can control polyphony, note length, density. You can do all the type of infilling that I was talking about earlier. And you can have new types of controls that didn't exist before these AI type of systems, where you can control the neural network itself. So you can control the entropy, which is through the temperature, which is going to tell you how typical versus non-typical out of distribution the nodes that are going to be generated will be. You can put a hard limit on polyphony. You can choose the percentage of bars in what you selected that are going to be modified. So you can take 2 tracks of a full composition and say, no, change me 70% of the bars. And then you can tell the sampling what is the size of the block that is going to be sampled at once. If you change all of the bar of a track one by one, then when that bar is being generated, the context has a lot of pressure on that bar, and there might not be a lot of options. But if you generate a block of 2 bars on 2 tracks, so that's a block of 4 bars, then there's a lot more freedom for the system because there's a lot more things that can be done by resampling all of that at once than one by one. So that's something I wanted to explain, and Paul will get back to it because this is the case in Reaper as well. So you get those control, and in Calliope, we don't have it yet in Reaper, but it will come potentially. You can do something that for a composer is and sounds crazy. You can batch generate, which means these variations of Mozart, I can do 1, I can do 100, I can do 1,000. And making 1,000 variation of a symphony is not something that composers typically do with those type of machine. And Marlon got a bug on the login of Calliope. Now, there might be an issue, or there might be too many people on the server at the moment. So in that case, I'll send an email to Renault. I tested only this morning the QR code, which was going to the web page, which was a good start. We're moving virtual machine at the moment at SFU, so it might be as well caught in that transition here, the joy of DevOps. But that's good to know. I'll take note and I'll follow up. So it will work. But for now, we won't have to rely on that today. So you can bash generate variations, which is something completely incredible. And then you can organize in Calliope, you can organize what is being generated. Yes, thank you, Casper. I got that. What is being generated according to the proximity to the original. And so you can take your own composition, for example, and then generate hundreds of variations and see which one are far enough. Of course, you can think of more nefarious use of that system, and that's where those systems are powerful and therefore problematic. And each user come with different values, and it's not the system that is going to be nasty, it's going to be potentially the user. So for example, if you want, you can take copyrighted music and then make hundreds of variations and go through the variation and be like, this one is similar enough to be really good, but it's different enough so that, you know, it wouldn't be too recognizable or it wouldn't be plagiarism. There's also a lot of composers whose job is actually to receive an order to make a variation, often to avoid copyright law. Like, let's say BBC has a documentary, it's going to go worldwide, then the studio get a call. Can you remake that music? Because we don't want to pay those copyrights worldwide. So there's all sorts of use cases here that are virtuous for some and problematics for some others. So back in the days when he started working, we got some attention by the industry. So, you know, as a researcher, you do something right when the industry is calling you. And we've been working with those models along the years with various companies. Elias is making software for composers working for video games. Video game is a really good use case because you need a lot of music, you need vast quantities of music. So that's really a good use cases where the composers can provide stems and important parts, and you can make transition between those parts, extend them, make variations. We've been funded recently with Audio Kinetics based in Montreal that is also working on software for music making in games. We've been working with Teenage Engineering, working with the OPZ and making an interface with, again, encapsulate one of our model because it works locally where you can compose or play some parts and conditioned on those parts that you wrote, generate other parts. A lot of people, they buy synthesizers, but they don't necessarily know how to compose music. And so they're more interested in exploring the sounds, but they have issues making musical patterns. We've been using those systems ourselves. And in fact, here I'll play these little snippets of videos of an album that I released using the OPZ and our system. All right. Yeah, example of use. I mean, yeah, that's what those systems are made for, to be used, and we'll talk about that a little bit. I have another 10 minutes for you guys, and then I'll pass it on to Paul for those who are in a hurry to see MIDI-GPT in Reaper and to install stuff on their computer today. Um, yeah, we made a plugin for Ableton, but I would not recommend it anymore, although it works um, as well, because we are about to release in the next months, maybe, another one with a better model, better interface, better everything. Ableton API got better, and that allows to do things in a better way. But we done that, and we've been funded and working and collaborating with Steinberg, and there is a version of the module in Cubase that we used, but for research. It's not released because of the dataset is being trained on. And when we do the research, I think it's worth saying. We are interested in different groups, but mostly beginners and professional. And here, when I say professional, it's literally people who make a living out of using the software. And there's a lot of people, composers, they make a living out of using Cubase. And so we wanted to do research before we deploy the system in every software, in every creative on behavior and workflow. What are the consequences? And not the consequence in terms of does the system work, because it sort of does. Does it allow you to work efficiently? It probably does. And we can test that and we show that actually, but more the human factors and the thing that we care about when we care about art, which is agency, control, expressivity. Is it the case that when you use MIDI-GPT, for example, at the end, you find that it is your music that comes out? And often that has to do with the way you use it. If I make 1,000 variations of Mozart, I won't say those variations are mine. But if I work really hard back and forth with the system for hours, that I feed my composition as an input, then what comes out is, the transformation of an artwork is always an artwork, is definitely going to be mine, and it's going to feel more like mine. So it's not those questions are important, and those interfaces and the way we're going to use those systems are going to really determine whether there's authorship or not. In a nutshell, is what I'm trying to say. So it does matter. And then, more importantly, maybe the phenomenology of it. If I'm a composer, and I won't say names, but through those studies, I met some, and you're 65 and you've been using Cubase for 25 years, because Cubase is 30 years old and it's one of the OG of the DAW world, the digital audio workstation. And then all of a sudden I put an AI in there and I say, because I'm your boss, well, you're going to have to use it every day now because it's a lot more efficient. Then how do you feel then? How would you feel in terms of the experience that it gives you, the affective, subjective, and aesthetic mark, not only on your music, but on yourself? In other words, do you feel like working or do you feel like vomiting in the morning? So we're interested in the lab, and I don't have a lot of answers for you in those type of experiment. In our case, for what we did research, what's interesting is we found that a lot of the beginners, they use those systems successfully, but they don't really feel a lot of authorship because they let a lot of the system content go through. While a lot of the professional we worked in and in that study it came clear, they use it as a what if machine. They generate a variation of their composition, or they say, oh, what if you had a marimba here or 3 violins there? And or do it again. Oh yeah, that's a good idea. And then they would go and write that part if they're inspired, because they can. And therefore they completely feel that they maintain authorship for what we find in those studies. So I wanted to mention the studies along the way. Another thing to be mentioned before I pass it on to Paul is we've been using those systems and entered the AI song contest. And for those who don't know it, I really recommend it. It's at minima a lot of fun, and it's a great way to see the sheer diversity of types of AI involved in music making and ways to use them, because there's about like 50 to 100 different entries, and every band is using AI in a completely different way for completely different reasons. So it's actually quite fascinating. And you see here we had an entry with Scale Plute back in the days, and there was more of a surf rock piece with a yeah, interesting, questionable production value. So I'll pass here, but I recommend the song contest. So we work with those systems ourselves, first person, but we like to work with other artists and beta testers, and that's why we're super happy to see you all here today, and we hope you're going to give a try to those systems. We've been getting some grants from the Canada Council as well that we need to acknowledge to work with artists using those systems at times. And we are organizing an artistic residency. So I don't know if there's a lot of French citizen in the audience, but it's for this year we already have someone. But for the last 3 years, yes, we had French composer coming in the lab and working with us. And that's the idea in research creation of participatory design. We like to design those systems, the one I presented and the one that Paul will present today with MIDI-GPT, to design them with artists, because we believe in participatory design. If artists aren't part of all of the development of those systems, then the typically bad decisions will be made and things won't go the way they should. Okay, so with that, I'll pass it on to Paul, and maybe I'll stop sharing. And Paul, I think you already have the right to share. I'm all exactly an hour long, an hour and 2 minutes. And then for the next 40 minutes, we'll see how long it takes because we never did it before. Paul is going to present to you MIDI-GPT, the repo, and then its integration in Reaper. Paul, are you here?
Yes. Thank you, Philippe. Hi again, everyone. So, so after this sort of theoretical outline of the current context and the model, I'm going to showcase the actual model in one of its integrations in Reaper. So I'll first go through kind of where everything lives, the different repositories on GitHub, where you can find the plugin and the code for running the model, as well as the installation phase of how to get things set up. So we'll go through that first stage, which might take 10 to 15 minutes. I'll just show you the different steps. I'm not actually going to run it for time questions.
So what we see now, Paul, is the AI
Yes.
Song Contest slide. Yeah. Okay.
Yes. I'm just prefacing before I move on, but I'll move on right now. Yeah. So we'll go through installation, and then I'll show you a few examples, maybe 2 or 3 within Reaper, and kind of just take you through my workflow, because once again, this is a tool, and so it really functions based on how you use it. And I have a specific workflow. I have a specific way I like using it. So I'll showcase how I enjoy using it, how I integrate it into my sort of creative workflow. But there are really no limits on how you can integrate this tool. Yeah, so let's get started on the first, I guess, section of this installation is the actual MIDI-GPT code. So the Reaper plugin is just an interface, and it's just an interface that calls a backend through an API. And that backend API is made using this MIDI-GPT code base. So I'm gonna show you this first repository. So this is the main repository where the actual code lives to be able to run the model as well as train it. So it's a pretty complete repository, and this is exactly what we use to pre-process the data, to train the model, and then to actually run inference, so to use it. You can install it manually. There's the instructions that are present here. You can install it by source, using compiling it, because it's made with C++ and Python. However, we have pre-compiled it and released it via PyPy, which is showcase right here. There you go. Which is Python's package index. Right here. So which means if you were to install it directly from here, you would have no compiling to do. So it would be pretty straightforward. You would install it in a few minutes and it'd be ready to use. So for most use cases, I recommend that you install it this way, so that you don't have to figure out how to or at least compile the C++ code. So how can you use this library outside of Reaper? So just the MIDI-GPT library. So it's a Python library, so you can use it directly via a Python script. So you can just import the sub modules of the package and then use it in Python. However, that's not how we're going to use it today. We have implemented an HTTP server that runs using this backend, which allows you to make generation calls over the internet. So you can even either run it locally and then so run, run the model on this over this HTTP server and call it from any interface. And so this is very practical and useful because it sort of makes a clear separation between the front end and the back end, which means you could technically implement any plugin on top of this. So that's sort of a general outline of the code repository. In terms of models that we currently have access to, the models are hosted on Hugging Face. So Hugging Face is a platform used for hosting AI models. Most of the time, large language models, but we also see some generative models for audio or music. So this is the Hugging Face page where you can find the models. Today we're going to be using the model we call Yellow, which is our first model, and we have a small and medium version. So for various reasons, the first one being speed. This model is able to run on a CPU in a few seconds per generation. So that's one of the I guess powerful aspects of the system is today with bigger and bigger models, we need bigger and bigger hardware, but these models can run on your CPU on most laptops. That's why we have two models, a small one, which runs nicely on CPU, and then a medium one, which you could also run on CPU, but it's going to be slower, and we maybe recommend that you run that one on GPU, or it's also compatible with Apple's Metal framework, so any of the new silicon chips. We are currently training two new models called Prism and Expressive. So Prism is an extension of Yellow that has a larger context as well as more controls. As you can see here, what we call attributes is what we call what are the controls that you can use to basically steer the model in a certain direction when you use it for generation. So the current model that we'll be using today will have note density for drums, and then for any of the harmonic instruments, it's going to be a polyphony range, so minimum and a maximum value, as well as a minimum and maximum value for the note duration. And then the models that will come out with soon. So Prism is going to have all of that with a larger context size, as well as a key signature, silence proportion, pitch class, and genre. Genre, I think, is one of the more powerful controls that we're going to release pretty soon. And then we'll have another version of that model called Expressive, which is going to add on top of that expressive features such as micro timing and also dynamics. We already have dynamics in our current models, but it's going to have a more finer granularity of dynamics, so for velocity. So those are where you can access the models at the moment. So this is the sort of backend that runs MIDI-GPT and is what's going to be used by the Reaper plugin. We do have a documentation for MIDI-GPT, so it's sort of helps you getting started and installation, as well as some examples and a quick explanation of the way that MIDI-GPT works, in a more technical sense. And then we have, most importantly, this sort of HTTP server, which is what we're going to be using. So you will need to run this HTTP server locally, and then on the you'll need to run the Reaper plugin separately. So this sort of separation between front end and back end means that you will have two sort of processes to run concurrently. And here there's a quick explanation of how the HTTP server works and what sort of payload is expected when you run this model. So I'm not going to get into specifics. All of this is handled through the MIDI-GPT Reaper plugin, but this just shows that for any of you who are programmers or or like to dabble in more of the technical side of music, you can implement your own front end plugin or system that uses MIDI-GPT as a backend. So now the second important repository that we're going to have here, which is more of the main focus of today, is the actual MIDI-GPT Reaper plugin. So like I said, this MIDI-GPT Reaper plugin uses the MIDI-GPT Python package as a backend. So this is, I'll share the links with you in the chat. Someone asked if we need an API key. So no, there are no, you do not need an API key. Yes, I will preface that this is meant for local inference, so I don't recommend, unless you make some modifications yourself and take full risk, I don't recommend that you expose this HTTP server to the public internet. There are some tools you could use if you want to host the model on another computer. That's what I use. For example, I use Tailscale, which allows me to basically have my own sort of VPN. And right now, what I'm doing is I'm hosting the model on a Mac Mini, and then I'm running the Reaper plugin on my personal MacBook. So which allows me to sort of use the computation of another computer and not have it overload mine. So yeah, there are no API keys needed for this. It's a service that you run on your own locally, so there's no authentication at the moment. Yes, so like I was saying, so I'm going to take you through the sort of installation of how to sort of install and get the Reaper plugin going. So we do also have a documentation here for this MIDI-GPT plugin that sort of explains how to install and then how to use. Yeah, so like I was saying, the plugin works through two phases: an inference server that you run separately via the Python package, and then the actual plugin, which is a dashboard that you can open using a framework called Rescript. For those who are familiar with Reaper, Rescript has its own scripting language, which is pretty powerful, allows you to sort of control the DAW programmatically, which is a pretty powerful feature, and which is what we use. And then we also use on top of that a framework called IMGUI, which is for the interface. So that's also an extension that you're going to need to install yourself. So I'm going to go through the requirements, all 5 of them that you need for the Reaper plugin. So most importantly, you need Reaper, obviously, to use this plugin. And for those of you who haven't installed it yet, it's a DAW that you can use with a free trial that you can extend indefinitely, which is why one of the reasons why we choose this platform as to host this plugin is because it's easy and accessible DAW. So if you haven't gotten Reaper, you need to install that now. And now once you're in Reaper, you need to install the extension that's going to allow you to render the actual interface. Which is called IMGUI and has the Reaper variant, which is RIA IMGUI. So for this, you will need something called RIA Pack, which is basically an extension that you can download that allows you to manage packages for Reaper. So if that's not done, you will have to install for your given OS the RIA Pack extension for Reaper. And now once that is done in Reaper, you can come up here in the top menu and see extensions, RIA Pack. And so then you could do, for example, browse extensions or browse packages. And you can search for RIA IMGUI. And you can see here, I already have it installed. This is the specific package that you will need to run the extension. So you would have to install this and then relaunch your Reaper plugin. And so once all of that is done, you will be your Reaper will be set for the next next phase of the installation, which is the actual Reaper plugin. So I'm going to come back to the documentation. Yes, and of course you need Python to run the actual plugin, because like I said again, it runs off Rescript, which is a Python scripting language for Reaper. And then you will need Git, and the compatible OSs are Mac OS, Linux, and Windows. So almost every OS available. So those are the requirements that you need. Python is 3.10 to 3.12. We recommend 3.12 as the version to use. So for simplicity, we do have a one-liner that you can copy and paste in your terminal that does the installation all by itself. So before you run this, you will need to make sure that all of these requirements have been fulfilled, or else it's going to tell you that you need to either install Python or install RIA or install the IMGUI extension. We also allow the possibility for you to then install or to update or uninstall the package. So I'm going to show you what the sort of folder is going to look like when you download it. So it's going to look like this. And you're going to have a few scripts that are going to be important for you to know. If you want to run the server locally, then you're going to use the start server command, or you can either run it separately by referring to this documentation here that shows you how to launch the MIDI-GPT server separately, on your own. And so basically the installation script that I just showed here is going to set up everything within Reaper. So it's going to give Reaper the appropriate Python path, as well as the path to the scripts that you're going to be using. And so once you run this, it's going to be pretty much set, and there's nothing else left to do. And so once that's done, you're going to go into Reaper, and this is where you're going to actually use the plugin. And so this plugin, because it's not a traditional VST like most of you have probably are used to using, it's a ReaScript we call action. So to actually use it, you're going to have to go here up to actions and then show action list. And so here you have a lot of different actions that are based off ReaScript. And so during installation, it's automatically going to put this new script within the folder that Reaper looks for when it's scanning the actions. So when you first come into this actions window, you're going to have to do new actions and then load ReaScript, and then go to the folder that was downloaded when you ran the installation script, which is going to contain all the source code for the Reaper plugin. And you're going to want to go into source, scripts, and then MIDI-GPT, and then select, okay, well, this is an older version, but you're going to want to select one that's called Reaper MIDI-GPT Dashboard, which name is here. And so that's the actual plugin that you're going to want to launch to use MIDI-GPT. And then what I do for simplicity, okay, quick question from the chat. Someone asked if the HTTP server should automatically download from Hugging Face. Yes, it does. It has the link, the repository name on Hugging Face, hard coded in the server, so it'll automatically check Hugging Face for the models that you ask and download them automatically, and then they'll be put in your cache, which means next time that you rerun the server, it will automatically see that you already have the models loaded in your cache. The models, though, are relatively small, with the smaller one being at 80 megabytes. So it's a relatively small model. So for what I do for simplicity and ergonomics is I add a shortcut to launch the script. So here with this add button, you can add a shortcut, and I usually do Shift Command and so which means that then when I'm here in Reaper, if I press Shift Command and, the plugin should appear. There you go. And so yes, so once you run the script, you can either run it, like I said, through this action lists interface by clicking on the script and then clicking on run, in which case it will run, or you can create a shortcut, which I recommend for ease of use. Great. So now we've made it through the sort of installation phase, and now we can actually get into using the plugin. So I'm going to do a quick pass of the different, I guess, modules of this interface and explain what they do. So you first have the sort of setup and actions section here. So like I was saying, because you run the server separately, you will need to provide the URL to this server. So if you were to run it locally on your local computer, on the same computer where you run Reaper, you would change this to, for example, localhost or 127.0.0, which is the address that default address when you run things on your local computer. I, however, am running it on a separate computer, so I provided the IP address for that, as well as the appropriate port. Yes, it's important that you provide also the port to the server. And so once that is done, the plugin will automatically go and query that server and ask it for the different models that it has loaded up. Because when you run a server, you can load specific models. You can load one of them, you can load two of them, and then you can switch through them when you call the API. And then it'll give you the different models that I have access to. So here I'm running a server with just the yellow models, like I said, and I'm going to use today the medium one. And then we have some different helper scripts that are pretty useful that basically set up your tracks, because MIDI-GPT works for all 128 of the MIDI instruments. So MIDI has a MIDI message that basically defines what is the instrument that is used for this track. And there's 128 of them. And so something that I didn't mention during the setup, we also have a recommended setup that you use to actually render the MIDI, because you'll have 128 instruments. You are free to have 128 presets that you want to maybe synthesize using your preferred VST, and then link those to the actual tracks that you're using. To get going quickly, we also we share a few VSTs and files that allow you to play the MIDI pretty easily. The first one is Esforzando, which is a free VST. Yes, a free VST that you can download at this link, and that uses a sound font file. So a sound font file is a file that contains samples that you can use to then synthesize MIDI. And so if you want to use this recommended setup, you would have to download the sound font file and the VST called Esforzando, and then follow the steps that are here in the bottom of the documentation. So you would download the VST, the sound font general MIDI bank. We also include this drum kit VST, which if you want a maybe more realistic sounding drum kit, you could download this one, and it's also free. And then here is how you would install them, and then have Reaper see them in the scan plugins. So yeah, this was to sort of introduce this setup tracks action, which basically is going to scan your MIDI tracks and then apply all the appropriate VST on it, so that you can just plug and play. I'm going to show you a quick maybe example here. If I open a new project tab, so here nothing is loaded, and then I load a MIDI file. So here I'm going to load just maybe Hey Jude by the Beatles. And so here you would expand into the 17 MIDI tracks. And so here you'll have all your MIDI tracks, but for the moment you have no VST. Just going to delete those because these are metadata. You have no VST loaded, so if I were to play, nothing would play. And so with this setup track, it's going to analyze your tracks, analyze the MIDI content. If there is the instrument that is embedded within the MIDI, it's going to automatically set that track to that specific instrument via the VST. So if I click on setup tracks, it's going to analyze the MIDI, and it should automatically detect, yes. So the MIDI has this metadata embedded, so you will have your tracks that are automatically sort of set up. And if you look at the effects file here, you could see that it loads the Esforzando VST with the sound font file, and it will load the correct MIDI instrument. Yes, sound fonts are amazing. And so now if I play, you should be able to hear it. So of course you are free to use whatever VST you want. This is just for quick use. And one important thing that you may have noticed here, which is very important to know, is that the plugin automatically renamed the track names. And why is that? Is because when you run the generation, it's going to basically copy the MIDI content from the Reaper and then send that over to the API. And like I said, MIDI doesn't always have the instrument embedded within the file. So sometimes if I were to, for example, create a new track here and then create a new MIDI file here and then write into that, there is no notion of instrument within that new MIDI clip that I created. And so how does the plugin know which instrument is associated to each track? It actually looks at the track name. And so this is shown in the here in the documentation. We have a instruments.md file. Oh, this is going to be, I have to fix that link, but which is basically defined down here. You have every single name that you're going to have to use for the associated MIDI program. And so if you, for example, you would want to create a new track with, for example, a synth bass, you would go and look for the appropriate name to use, and you would copy that and then place that into your new track. And then that means when the plugin analyzes your track, it will see that as the synth bass, and so condition the generation appropriately. And so this setup track just does that automatically for you. But if you want to use your own VST or want to have a little more, control, you can then do all of this manually. And why this control would be useful, because sometimes it's important to see the instrumentation of a track, not necessarily as how it's going to sound, but how it's going to condition the generation. If, for example, I want my generation to have chords, I might pick an instrument like a piano or maybe orchestral strings that maybe are more for which the ground truth data has seen more chords. But then I'm free to choose whatever synthesis VST in the effects pipeline. So that's sort of the ways that you're going to use this instrumentation. Using this instrumentation with the Esforzando VST is basically just going to play the appropriate instrumentation. So that's how you set everything up. And then, so if I go back to this folder, which I'm going to use here, yeah, so that's how you set everything up. And then here you have the run infill, which is basically the button you're going to click to generate. So how do you generate? I guess this is the most important question, how you actually set something up for generation. That's going to be done by selecting the clips. So for example, if I were to select this entire clip, I would generate all these bars. If I were to select these bars, then I would only regenerate these specific bars. And so here, for example, if I were to click on these and then generate, it would infill these bars. And then you have controls. So these are parameters for the actual generation. For those of you familiar with deep learning techniques and sampling, might be familiar with temperature. Temperature basically defines how chaotic the generation of the system is going to be. So something low, the model is going to be more on the safe side and generate something that it's very sure about. Whereas if you have high temperature, it's maybe going to sample something more chaotic that's not necessarily going to sound better. It just means that the model generates based on less, I guess, predictions that are less sure. And then importantly, we have this context size that basically defines how much bars your model sees during each generation. So our current model that we have, the yellow, just has 4 and 8 as compatible sizes. So you'll have to make sure that you select 4 or 8, which means that if, for example, I were to set 4 as a generation, and then I would generate only this bar, my model, when it's going to regenerate that bar, is only going to see these 4 bars, because I set the context size to 4. Whereas if I set it to 8, and I have this bar that I want to generate, the model is going to see the entire MIDI content that I have here, because it's 8 bars. So that's sort of how we're going to use that. And then another parameter, bars per step and tracks per step, basically defines how many bars and how many tracks you can generate within each step. For example, if I have, I'm just going to click 4 random tracks here. If I have 4 tracks that are, 3 tracks, sorry, and I were to select something like this, if I were to have tracks per step equal to 1, the model is first going to generate this bar on this track, and then generate the bars on this track, and then generate the bars on this track. And so you sort of get this sequencing. And you know, you may intuitively think, well, why don't I just set it to the maximum so it does everything at the same time and it's quicker? Well, sometimes you may want to sort of have this lower tracks per step, depending on how you want to, you know, sort of condition condition your model during the next step, which means that if it generates this, this is going going to be seen as ground truth and context. And so the model is going to treat what was generated before differently. Yes, and then so that's for track for step, and then for bars for step, it's the same idea, but on the bar dimension. So if I were to have this, for example, I want to generate these two bars, and I would have bars per step equals to equal to 4. It's basically going to have a window of 4 bars and generate whatever's in that window. So if I were to run the generation now, it would generate this bar first because that's in the first window of 4 bars, and then generate the second bar that's on the next bar of 4 windows. So those are how you can sort of control the granularity at which you generate using this bars per step and tracks per step, these track per step parameters. And then you have these other parameters which are for sampling as well. You can supply hard limits for polyphony and density. For example, if you want the model to explicitly never generate more than a monophonic, then you can set these hard limits. Same for density. A density is basically going to be defined by how many notes you have in a bar. So if you don't want the model to go over 8 notes per bar, then you can set this hard limit. And then we have sampling parameters, which sort of define sort of like temperature. What are the different possible notes that the model is going to sample from? With top P and top K being the most common parameters that we see. Top P basically means that if I set top P to 0.9, the model is only going to consider the notes for which the probability of the model sampling it adds up to 90%, which means it's going to discard some of the low probability notes. And so this can sort of give you a sort of stability. And then for top K, it's going to keep, for example, if I set top K to 25, it's only going to consider the top 25 notes or tokens at every time step. So these are sort of for stability. And then for diversity, you have the opposite phenomenon where the model sort of excludes the top 5 tokens, for example, if you use the anti-nucleus mask for K. And then for reproducibility, so as you know, generation is always random. It's one of these sort of ways we sort of get some sort of proxy diversity and creativity when we generate. And if you want to reproduce exactly the generation that you had before, you can set a specific seed. And that means if you have the same context, the same content, and you regenerate with the same seed, you'll get exactly the same results. And you can set it to -1, which means that there is no seed and the model is going to generate something different every time. It is important to know that the model can sort of fail generation at times for multiple reasons. And so you could have a number of attempts to go for. And some of these attempts, you can apply a temperature escalation, which means that at every attempt, the temperature increases. And why is that we increase temperature at every new attempt? It's because maybe we enlarge the possible number of possible nodes to maybe allow the model a larger range of possible nodes to generate from to allow it to succeed, because some of these failure nodes happen because of some of the checks that we do when we generate. We check that the model generates novel content. That means if I were to generate this bar, I'm going to check that the model generates something different. Otherwise, that's a fail. Or I also check that the model generates anything other than silence, because we don't want to generate silence. Or you can set that to both. And then finally, some of the concepts that Philippe was talking about, the batch generation, is with this parameter here. And so you can ask the model to generate 6 different generations, and then you can sort of toggle through them and then listen to them and then choose one as a definitive result. So those are the global parameters that you have to control the generation. And then we also have per track parameters. So if you go down here, you'll see the track controls. And so these are for track-specific controls. So you can control polyphony and note duration through sort of explicit controls using for each track that you generate. So for example, if I were to generate this whole track, with polyphony, minimum polyphony equals 2. That means the model will never generate monophonic. It will always generate at least 2 notes at a time, as well as note duration and note max. Something important, if you leave them to any or 0 for the slider here, that means the model is going to choose what controls it wants for polyphony and minimum and maximum, and then for note duration, which basically means the model is going to choose for itself. So that's sometimes if you want to control the model in a specific direction regarding polyphony and note duration, you'll want to set these on. And so something that I was explained before, where you select your generation by selecting the MIDI clips on Reaper, is that there are sort of 2 modes of generation, which Philippe showed earlier in the image, where you could see the tokenization. Maybe I'll just go back to that slide quickly. Yes, this one right here. So we have 2 modes of generation, a autoregressive mode and then a bar infill mode. So the first mode, autoregressive, just means that the model is going to generate a new track conditioned on all the other tracks you have. So that is useful when you want to sample a whole track by itself. When you want to generate bars per bar, then you'll use the infill mode, which just is going to replace the content within that specific bar. And so it's important to take note of these 2 sort of generation techniques, because it's one of the parameters here that you have when you generate. If I click on autoregressive here, no matter what I'm selecting, the model is going to regenerate the entire bar. And it's also important to know that it generates it at once. And so this is important if you want to, for example, if I want to regenerate this track, but sort of get a variation, then I'm not going to do autoregressive. I'm going to do the infilling mode by using a bar per step that's low, which means the model is going to generate 1 bar at a time. But because it's going to see the other bars that it hasn't generated yet, it's going to be influenced on these other bars that are already there. And so as a result, you get a sort of variation of what was already there. So those are how you can sort of play around with these 2 generation modes, depending on what results you want to get. And then there are, for each track, there are 2 additional features that we have. You can apply a pitch mask, which means that if you want to force the model to generate at a specific scale, then you can apply that scale here. And then that means your notes will fall within that scale. And that is useful if you have specific constraints, a specific scale that is present in your session, and you want to enforce that strictly. And then a remix, which is another way of game variations, but I'll explain that later in this workshop, once we get some actual generations through. So that was a sort of walkthrough of everything. I'm just going to check the comments, any questions in here. Oh, yes, one of the people, yeah, make sure that when you go find the repository, that you go on the Metacreation Lab, yes, GitHub. I'm going to post both repositories here in the chat so that you get the correct one. Great. So now that I've gone through all of these controls and everything that's present here, yeah, one thing I forgot to add, you have a console here which sort of gives you some logging. So if you have an error, you'll be able to see what this error was about, and sort of make sure that things work. Yes, there's a question. That's from Teresa, I think. No question? Okay. Okay, then we'll move on. So I'm going to actually now get into show you some examples of how I would generate this. So here I have an example of a classical piano back song. So I'll make you listen to this sort of excerpt that I want to work in. So I'm going to walk you through some examples of ways that you can use the plugin here. So the more straightforward way, without having to set up any parameters, would be to just select, for example, say I want to regenerate these 4 bars here, and I want the model to generate them all at the same time. So I'm going to set bars per step to maximum and also tracks per step to maximum, which means the model will generate all these in a single pass. So then when I run generation, here you can see that the nodes come in. And one thing interesting that we added is we gave you some sort of information on the generation, because one of the limitations of this model at the moment is the sort of context size. As you'll see when you use this, if you have, for example, the context size for bars set to 8 bars, and then you have, for example, 12 tracks, especially with drum tracks where there's a lot of very high density of notes, you'll find out that the model actually runs out of space, which means that it can't see all the notes that you're using that are in your tracks. And so we sort of give you this visualization to see where you are in terms of filling up that bar. And some quick tips, if ever you were to, for example, fill up that bar and have no more room for generation, you could go down here and ignore tracks, which means that the model will completely omit that track in its context, which means that you can decrease the number of tokens that are added and have more room for generation. And then it tells you how many tokens you had in the prompt and then how many tokens were generated, as well as some speed information. And also something important, if you did not specify a seed, it still gives you the seed as a result. So you can always copy that and then come back to explicit generation here. And so I'll make you listen to the results just to see the quality of the generation. And so that was one way. And then I'll maybe show you one of the ways that you can sort of play around with bars per step to see how it can get you different examples. For example, if I were to generate this section here with a bars per step set to the maximum, all these 4 bars are going to be generated simultaneously, which means that this sort of motif of very rapid arpeggio is sort of going to disappear because the rest of the context sort of has a different style, which means the model is not necessarily going to reproduce this very rapid arpeggio. So if I were to show you this now, unless it would be to condition on this, but yeah, like I said, it did not generate something that has a similar motif. But if you want to sort of conserve that,
and it took more influence of the part before, interestingly, because that was part of the context, maybe. Oh, no.
The context is yes. Something I forgot to mention. If you want to sort of force the model to only see a specific section, you could use Reaper's loop mechanism, which means the model will be constrained within this loop.
Yeah, so you can mask the window of attention that the model has that way.
Exactly. And so if I set bars per step to 1, it means the model is going to generate 1 bar at a time. In the current, if you just do that, it's going to generate this bar first, and then this bar, and then this bar, and this bar, which means when it generates this one, it will see the neighboring bars and maybe can be conditioned on them, and therefore conserve the style of that subsection or motif. And so it's important to note that it does this sort of left to right. If you sort of want the model to generate the bars randomly, you could come down here and click on shuffle steps, which means it's going to sort of randomly generate them. So if I have shuffle steps and then bars per step set to a very low value, or the minimum, in this case 1, then the model should generate something that's, yes, so generate something that's more in the motif. And then if I keep going, it's going to stay within that specific style. And not always, like I said, because it's conditioning, the model sort of chooses, it sees the entire context here, and it sort of chooses what to generate. So it could maybe anchor more on something else, but you can see at least that it's one of the methods in which you could sort of steer the model towards sort of local consistency, like I was saying.
Can we listen to it?
Oh, yes. So this one seems to have a lot of it. One seems to have a lot of repetition. So in this case, we want to regenerate. Yeah. So the thing with this system is it's it's really an iterative process. You're never going to get what you want off the first, with the first try. So that's why, you can start with generating a whole track and then identifying bars that you don't like, and then regenerating those, and then iterating until you have something that you maybe are more satisfied with. And of course, what's great is this sort of collaborative process. So you can always, open the clips and then modify things yourself, and then the model will be conditioned on that. And so it's a sort of collaborative process between you and MIDI-GPT. So here I'm maybe going to introduce the last thing that we didn't really look at, which was the variation, which we call remix. So if I click on so on the first track here, and I click on remix, it means that the model is going to regenerate only the pitch of this of the melody, which means that it will conserve the actual positions of the notes. And this is another way that you can maybe get a variation. If you like the rhythm of your motif or of your chord progression, but you really just want to reorganize the pitch, then you would click on this remix, and in which case it generates just the pitch, and then you can specify how many of these pitch tokens do you want resampled. So if I were to, for example, resample this whole track, so I'm going to click on auto-regressive, so that samples the entire track at once with the remix on, and say, for example, 50% of the notes, 51, you'll see that the actual time positions, so it looks very similar because the actual onsets are the same, but the pitches are a little different. So that's one of the ways that you can get variation. And of course, you can sort of regenerate everything by moving this up to 100%, in which case you would resample all the pitches. And then you can also ask whether it generates only the pitches or the durations also, in which case you might get longer tails for your notes. So that's a quick overview of the different features that you have for as generations, and how you might use some of these parameters. I didn't really explore some of these sampling techniques, but just to show you maybe a quick example of what a very high temperature looks like. So you can see this sort of chaos. If I increase the temperature to 2, usually we want to stay within 0.5 and maybe 2 as a maximum, because over that value or under that value, the model either collapses or generates kind of very, very chaotic. And I'll show you what this looks like with a very high temperature. So here, if we were to listen to that, it would not sound very good. Maybe we can isolate the track. Yeah, so it's important to know that temperature just means that the model has a maybe more larger possibilities at each step, and weights some. So what happens with temperature, it means some of the very probable notes are decreased in probability, and some of the less probable notes are increased in probability. So you're basically steering the model towards generations that it's less sure about, and so you might, as a result, you might get results that are less quality.
Yeah, you're steering it toward equiprobability at the maximum, and equiprobability means it's random.
And then very, very low temperature means the model generates exactly what it's very sure about. And in this case, because we have another track that's used as condition, you're most likely going to get a copy paste of what's here, but we'll not 100%, but we'll still see what happens here. Okay, so we don't get a complete copy, but you can see the sort of generated motif seems a little more simpler than what you had before, with maybe a more fast-paced arpeggio. Here we see more longer notes, high durations. So maybe we can see that as something the model is more sure about. So that would be the influence of temperature, and then you can explore with top P and top K, which sort of do something similar in the sense where it eliminates very low probability options for the model. So that's sort of a quick outline of the plugin, and maybe I'm going to walk you through maybe an example of a workflow how I would use this model, to generate a song from scratch. One of the ways I like using it is to generate something from scratch and like kind of let the model guide me towards a specific space or a specific genre, because it's important to know that the model is multi-genre. So it's seen content from pop music, electro music, rock, classical, folk, jazz,
Samba.
many genres. However, we do acknowledge that it does have sort of Western music bias, just multiple reasons from what's available as content out there, and also because MIDI is sort of rigid in the sense where it requires pitches to follow the the scale of the piano. So it's formatted towards a specific subset of music, which is more Western music. And so here, for example, this I generated from scratch earlier before this workshop, and it's a simple baseline, and I'll show you kind of how I would sort of go through and creating a song from scratch.
Can we listen to it?
Yes.
And take your time, Paul. Everyone, we're going to be running a little beyond the 2 hour mark for this workshop, is what I'm realizing now. So I hope this is agreeable for everyone. Hang on, everyone. We're getting there. But I think this is important. You should go through all the workflow, Paul.
Yes, and so someone in the comments says that temperature feels like entropy, and you are actually 100% right. Temperature changes the entropy of a model. Higher temperature actually increases the temperature higher temperature increases the entropy by flattening the distribution. So that's why it may seem as like it's entropy, because it's exactly what that is. So let's listen to this baseline. Yeah, so something maybe to note here is you might notice my time signature is 3/4. So the model does support multiple time signatures. I think it supports up to maybe 8 of the more common time signatures. So 4/4, 3/4, and maybe some other more common ones. So you should be able to play around with time signature too. And so here, for example, show you how I would use the sort of automatic setup. I create a new track, and I might want to set it up automatically. And so here I might, it gives me all the 128 MIDI instruments. So here I'm going to take maybe a sawtooth lead. And so as you can see, it already made automatic set up the name, and it set up the correct preset within the VST, which means that at this point I could just create a new MIDI object, and then I want to generate the entire track. So I'm going to click on autoregressive. But maybe I want monophonic, so I'm going to click minimum and maximum polyphony to 1, and I'll kind of let the model decide what sort of duration it wants to set. And I'll set the temperature maybe just under 1. I find that that's a sweet spot for me, maybe 0.9. Between 0.8 and 1 is a sweet spot for me, without getting something that's too simplistic, but also without getting to that very high entropy sort of chaotic space. And then I'll set the context and bars per step and tracks per step to max, even though because we're doing autoregressive, it's not relevant here. And then I'll sort of set things back to default here. There we go. Awesome. So when I generate, you can see the models, the notes streaming in. And so here, for example, it's sort of, read the motif of the bass. So here, for example, is maybe where I want to add a variation. So there's multiple ways. Either I could just regenerate with a higher temperature. So if I regenerate with a higher temperature, it generates something different. And so here, for example, it generated the silent bars. So I maybe want to regenerate those bars, but maybe let's listen to the second half. So I'm not too satisfied, so I'm going to regenerate. Maybe decrease that, and sort of I just generate until I see something that's maybe interesting to me. So then maybe I want to add let's add a electric piano and do the same process here. I'll click off autoregressive and then generate the track for the electric piano, so autoregressive. And here maybe I want chords, so I'll choose something polyphonic here. So generate this. There you go. Surfacing. Here we have something a little more interesting. And so I would sort of go through this process and then I'm not too happy with this lead, so I might regenerate here.
And of course, you can also play your own parts or import things from other pieces.
Exactly. So I'm going to regenerate the base, maybe get something different. So I'm going to regenerate from scratch and see what it generates. Now I'm going to want to add some drums, which I think is next after. The drums is all the way here in the bottom. And so the controls for drums are different. As you can see, you only have a density control because polyphony and duration are duration is not something you find in drums. We just consider the onsets when it comes to drums, and then density is basically going to define how many notes you have per bar. So generate this track. Get some variations here. I'm regenerating. So yeah, so that's unique sort of add drums. If I want to, maybe one way I like adding, maybe drum fills at the end is I sample this, I select this last bar here, and then I set the density to a very high value. I remove auto regressive because I don't want to generate the entire track. And then I generate, and then usually I get a higher density, in which could be a nice fill. So maybe I'll move on to, this was an example of another from scratch piece that I made. I'll maybe make you listen to it here. So this was an example of a track I made from scratch. I started with this piano here. I also drained from scratch. And this is maybe a good opportunity to show you the sort of remix mechanism that I was showing you. So yeah, here, for example, I have a pitch mask because I want my piece maybe to be in C major. And so if I maybe remix it by having the model just resampling the pitch and keeping the onsets, you'll see that it will generate a slight variation, but while keeping the sort of overall rhythm. So it's a little different, but it sort of still follows the same chord progression. Why does it follow the same chord progression? We also have these tracks here, which it's conditioned on, so it sees at every bar what is the correct chord to follow. And so maybe I want to generate something from scratch here. So I have this flute, maybe that I'll generate auto-regressively here to show you. Yes, and then here maybe is a good example. As you can see, I'm sort of reaching the end of my context. So for example, sometimes I'll remove the drums because the drums sort of provide a lot of tokens because they're very dense in notes. So sometimes I might just want to click ignore drums if I want to, create more tracks. I'm going to have to filter out some of the tracks that are already there. So here we have the flute that was just generated. So maybe I think that these last two bars are a little empty, or at least these ones here. So I'm gonna infill these. Remember to untoggle autoregressive when you're infilling, because autoregressive generates the entire bar. And so here I would get a variation, and so maybe a little more notes. And so yeah, so that's sort of a workflow I would have, when generating things from scratch, and then sort of iterating, doing remixes, replacing bars, and so maybe one last thing here is, if I maybe want to create a different variation of this, I'm going to set maybe bars per step to 1 for the flute. And then shuffle my steps, which is right here, perfect. And so when I generate, maybe I'll have a similar variation of this. So you can see the sort of durations and onsets seem similar, but we do have a different one. Yeah, so that's one of the yeah. So how I would sort of create variations, these things. Yeah, and so yeah, one of my workflows is I like generating things from scratch and then just seeing where they get me. And then of course you can always take a pre-existing piece. Here for example, it's okay, Jude. Of course these are they're not copyright-free music, so we're not sort of sharing these, but these are just examples of things that you could do. So here, for example, I just loaded this Hey Jude MIDI file, so I'm gonna set up the tracks. And so it'll take me through, yeah, so it automatically finds it, and then if you play, it should be correct. Yeah, so here I might want to create a bit of variation. So first what I'm going to do is I'm just going to sort of set these, so I could just select these. So here maybe I'll delete the drums and then create a new track that's going to be, could be anything, could be maybe let's do a banjo for fun. So take a banjo and then create my track. Sorry about that. So select autoregressive and then see what the model generates. So you might see it might generate a similar motif to what you already have in the other tracks. Maybe do something similar. And so here you kind of see you kind of find middle ground between what already exists and then maybe the model's internal representation. So let's listen to these 4 bars here. So one important limitation here, and I think this is pretty nicely demonstrated, is because we have a fixed context size. What happens when I ask, for example, the model to generate, I think here it looks like maybe 24 bars or something like that. What's going to happen is we're going to generate using an 8-bar window here, and then we're going to generate using an 8-bar window here. It's basically the window is going to slide, and so the model basically loses focus of what it generated a few bars after once the sort of model slides to the right. And so you'll actually, you might see that the model drifts away. And that's one of the reasons why, one of the next steps is sort of getting a larger context size, is so the model is able to sort of retain larger knowledge of what was before and what is after, so that it sort of stays within the boundaries of, of the correct style that it's currently generating. Yeah, so I'm just going to restrain myself to maybe these 8 bars, maybe regenerate these last 2 bars here, and then maybe we can then regenerate maybe some of maybe the French horn, maybe regenerate the melody through an autoregressive manner here, and see what sort of variations we get. Maybe I want maybe shorter notes, so I'll maybe set a note duration min and max maybe to 16th, between 16th and third and quarter notes. Let's see if we get maybe something a little. Yeah, so I think we have shorter notes here. Yeah, so that's sort of demonstration of how you could take a pre-existing piece and then sort of create variations or create on top of it, modify some things.
So the idea all through is that the music is the prompt, and part of the prompt, as you saw here with the banjo, um, is the instrumentation that you chose, and then it generated, I thought, something that works well for that instrument, and often you will generate things in a way where if you would want to play, because MIDI doesn't sound necessarily really good, you would want to play that part on that particular instrument, you can. And then you get the style of the music and the ethos from the rest of the musical context as well. So if you start with jazz, it's going to typically give you jazz. If you start with techno, it's going to give you techno, etc., etc. So here it's happened to be pop, but it's usually capturing that as well implicitly. Paul, do you have more for us?
I think maybe we could wrap it up here. Maybe I'll just show you with yesterday when I was playing around with the same file, and then I did maybe like.
And then I'll do a little conclusion.
Yes, dozens of generation. This is what I could get with a variation of Hey Jude. That's how you could sort of start from something existing and then still go keep the general style, but have different melodies, different chord progressions, and ultimately a different style.
Mm-hmm. Yeah.
So go ahead.
Okay, awesome. Is that it, Paul?
Yeah, I think that's sort of a quick overview. I know we didn't go too much in depth in how you could in many generations, but there's a lot to unpack when it comes to the entire plugin. There's a lot of parameters and sort of workflows to get accustomed to and to get used to, and also ultimately a lot of exploration on the exact influence that some of these parameters might have on the results you get. So
absolutely.
Yeah.
So we hope you're gonna get to try it, and we welcome your feedback, everyone. You know where to find us. Complementary to Paul, I'll do a little conclusion now. But it's also worth noticing, and you saw there's a lot of parameters. It was a lot to take on. So this is recorded, and so we will post the recording, and you can go at your own pace and revisit that when you're like, what did he say about this slider? Or how do you install this or do that? But that's sort of a design decision we made so far in that version, where everything pretty much that you can manipulate with the actual model, then you have access to. And that implies sort of understanding the model a little bit. That's why we did this sort of rather long introduction to it as a premise. And hopefully now you have everything you need to understand and fully control that model that is quite amazing if you want my opinion. There's also Paul showing you his way to use it right now, for example, from scratch and building up things like that. Of course, everyone will have different practices. Some people will use it between parts they compose to make transitions. Some people will make continuations of things. I just finished, I'm working right now on a project where I extend a Wagner, the opening of the Rheingold, for example, with materials that I co-create with MIDI-GPT. And so there's all sorts of artistic projects that you can take on and ways to use it. And of course, that the thing with these new systems implies that new practices are being born. In fact, most of you would probably know live coding, which is this idea of coding usually with text languages live the music and generate the code that will generate the music live. You can sort of use, because you saw the generation is fast enough that you can actually use MIDI-GPT live. And with Paul, we have rehearsal, we have a little gig that we're preparing for, and Paul is using MIDI-GPT in that way as well. We decide on a key and there's content, and then we can generate new content, condition on the old one, listen to it, and then if it's good, play it there as well. So there's really new practices, new musical practices that are born out of the emergence of those new systems. Myself, I don't use it by generating some from scratch, unlike Paul. The system has been trained on so much data and music that, you know, often you might get like medieval classical music or something like that if you start from scratch. So it's complicated, but everyone has a different way to do it. And if I start from scratch, I would start with the beat, and then often the type of rhythm I would choose would condition the modeling going already in a style that I want that particular day. But there's a lot there, and so hopefully you get to explore with it. And with that, I'll just conclude a few words and a few pointers, and maybe going back to the meta level, and as we transition between this workshop and the rest of the workshop series. So those generative systems, they're really not new. I gave you a glimpse of history earlier, and what's not new as well is those waves of automation in our societies, and we're facing a new one that is for sure. And often there's strong reactions, both positive and negative. Often negative. You see here some illustrations of what happened when physical work was automated by the automation of, like the invention of mechanical work, and then mechanical reproduction of music later on, and less, you know, in cinemas and theaters, less live musicians. There was serious pushback, serious consequences. And right now we really are facing a real divide around AI because of the potential implications and some of the dominant discourse that is selling it as being all gloomy. And there's a strong, and I think very well justified, anti-AI sentiment and polarization. There needs to be, we need to take back control and reign over those technologies. And instead of being pushed this wave of inevitable AI by the industry, we can ask the question, what AI do we really want and for what? And be a little bit more nuanced, because in all truth, and I think that's what these workshops hope to show, amongst other things, on the less pragmatic side, you know, beside the tools, is to show that eventually it's not going to be all AI and AI slop or zero AI. It's going to be an in-between, and it already is. And there's all sorts of socio-ethical settings, and they're all not common. There's corporate AI, and there's AI commons, there's open source versus commercial product, and there's all sorts of different types of AI attached with different set of values, and we get to choose which one we want to use. And so I'm a bit militant for the introduction of nuances, so as to depolarize a little bit the discourse and make it more interesting for all. So I will finish today before thanking our sponsoring partner by an example of use of MIDI-GPT I was mentioning. It's a very quick example of the MIDI-GPT composed material being played live at MUTEC in 2025. MUTEC, which is in Montreal, this next week actually. Yeah, so to conclude, we really believe at the Metacreation Lab that machines are not here to replace us; they're just tools. We believe in anthropocentric instrumentalism. We get to design those tools as artists and with artists, and instead of trying to replace artists, we can use those tools as they've been used in media art, in computer art for decades now. Not to debunk art and creation, but to harness and the power of machine to expand, support our creativity and expand it towards new practice. So with that, I want to thank all of the people who participate in the making of the system. And there's way more than I could fit on that slides here. There's online courses about generative art and computational creativity for free on Cadence, and I recommend Cadence because it's the MOOC that is teaching. Even I work for SFU, but I don't work for Cadence. But this is the MOOC that is trying to democratize art education, including digital art, and I recommend it. If you're interested in SFU, we also have programs, and we're trying to upskill since it is now a national priority in the AI for All policy. We try to upskill everyone, and so we're opening at the School for Interactive Arts and Technology, where I work and teach. We are opening some of our AI classes, AI and design, generative art, to anyone really. And so if you're interested in taking a class without taking a full bachelor degree, then this is not possible. And I know that it's not very well known. And then if you want to meet us or follow our research, we will be in September at Ars Electronica. We will be at AI Music Creativity, which is a conference on the use of AI in music that we helped started a few years ago. This year it will be in Berlin. Next year it will be in Montreal. And so we're really excited about that. And then if you want to find us, we have a website. And in conclusion, I also want to thank the Canada Council for the Arts, the Social Science and Humanities Research Council of Canada, and the National Science and Engineering Research Council of Canada, which are funding the research that is leading to the tools that we presented today and their evaluation. And we thank them for that. And then I want to thank you all for sticking to the end and listening to us today. I'll go back very briefly here to the beginning, to the list of workshops, and so the forthcoming ones are Autolium, Fragmenta, and Model Bending. I hope you have an interest in these too. So for those who will be there, I will see you all at 10 a.m. PST, Vancouver time, at the same place tomorrow. Thank you, everyone. And now that I finished this conclusion, we can take a few Q&As. So Paul, you're right, and you're still here. And so if you have any questions, anyone, now is the time to ask them potentially. And you can unmute yourself, or you can go into the chat. Any question, anyone? Fabricio says that we answered the question. I'm going to go on my last slide. Yeah. Okay. If there's no questions, and it was a long workshop already, then we can dismiss here. Maybe, Paul, do you want to answer the question of Lou?
Yep.
Yeah. Yes. So the first one about Yellow, Prism, and they're just names for the models. If you look at the Hugging Face link, you'll find that Yellow is our base model, which only has context size of 4 and 8, and allows for polyphony and duration controls. And then Prism is gonna have additional controls such as genre, silence density. So, if you don't want the model to generate any silence, you could control that too. And then expressive is going to be an extension of that as well with expressive generations, which means that right now the model generates sort of it does generate quantized MIDI. I think we generate at a resolution of 12 tick recorder note. So I think it's triplet 30-second notes that we generate. But of course, expressive music sort of has micro timing, and so we're adding micro timing as a result of the generation. So it would allow you to get more, maybe a little more expressive music out of the model. So those are the sort of three models that we're working on. And then the second question I just answered in the chat. Someone was asking if we could apply a different pitch mask for each bar. So we cannot at the moment, but those are things that are easily implementable in the plugin. And so this is sort of an open source plugin that was made very, very recently. So feel free if you have any requests, or even if there's things, if you find any bugs, we would be more than happy to learn about those. So don't hesitate to be active on GitHub. You could open issues, or even request features on there. Or even shoot us an email. We'll share. We'll be in contact with a sort of review overview of what we did with some of the slides and maybe some of the content that we looked at today. And so you can always contact us if you have any questions or requests about this system.
Can we do one more quick question, please?
Yeah, no problem.
So I was wondering if it's easy to fine-tune MIDI-GPT on recorded MIDI datasets, multi-track if that's needed.
Yes.
And how much data would you need before it would converge, and what would it be easy to overfit? Would you be able to retrain in a live context? I have some questions.
Yeah, that's a great question. And so we don't have a fine-tuning method yet within the code base. I mean, it's something that we could also implement, or because it's open source, if you have knowledge in training models, you could also implement it yourself. The training pipeline is there, so it wouldn't be too difficult to modify that. Otherwise, you can we can put that in as a request.
Yeah.
And in terms
it is in the plans to go toward that idea of model personalization. And if you attend the other workshops, in fact, MIDI-GPT is a bit behind there, because in all of the other tools we have really made foray into personalizing the model, whether it's LoRa's for diffusion or even fine-tuning of diffusion model. For MIDI-GPT, there's no support for that for now, but it is an open source project, and so contribution that would be awesome, and that's definitely things we are applying for funding for, and a great PhD topic. Paul, I give you back to it because I interrupted
yes.
your answer.
So either, if that's something you want to attack, you can do that yourself, or you can maybe be a little more patient and wait for one of us to get to that once the time arrives. Because like Philippe said, it's definitely within our sort of scope of things that we want to do. And then it's the second part of your question regarding the data. So to give you an idea, MIDI-GPT is trained on 2 million data MIDI files, and we do augmentation, which means that we select random tracks, we select random bars, we do pitch translate. So the amount of diverse content is pretty massive. So the model has a good foundation of understanding of music theory and such. And I don't have an answer to how much data would be too much, too little. That is something that would have to be empirically tested. There might be some estimations and theoretical estimations you can get through maybe looking at the model size. The model has a certain number of parameters, and there's sort of scaling laws where they set the number of tokens that you need per parameter. But then that also depends on the diversity of the data. It depends on the diversity of the pre-training data. It depends on the diversity of the fine-tuning data. There's very variables and I can't really give you an answer at the moment.
No, I understand.
But I mean, it's definitely more like if you have maybe 12 MIDI files, it's definitely not in that scope, range of maybe dozen.
What we've been doing is recording MIDI while rehearsing, and then we hope to have a model give us real-time data while playing. That's what we've actually
Yeah,
been
so
trying
that's the idea. I didn't talk about that today because it's computer-assisted composition, but one of the branch of research in the lab and something we are doing ongoing work on is musical agents. And in fact, you will see that we are with MIDI-GPT, Paul, myself, and Kian Lee, who's doing his PhD on musical agent. We're working and we will release soon musical agents based on MIDI-GPT that does not only continue what it does, but also listen to what others are doing, form expectations, prediction in a way of the future of what the others are going to play. Sometimes those predictions are ground truths. If you play along a composition that you know, for example, you're playing jazz and there's a chord progression ongoing, so you know somewhat where you're going. But sometimes you don't in free improvisation, for example. And so you make prediction of what the others will do, and then you infill the future and play it. And so we're working on architectures like that and trying to see if those models are good enough for those type of applications. Yeah, in musical agents, there's a lot of work, and we think that model would qualify to be tried. So that's a good idea.
Okay.
Any other questions today?
I'm working on the musical agent as I speak, so I hopefully
Kian is here,
sooner
actually.
than later I can make it happen.
Yeah, absolutely. And there's plenty of other architecture of musical agents that exist already. IRCAM is releasing good ones that are free in Max. There is a survey we did a few years ago with Kevin Stata when he was doing his PhD with us. And I think at the time there was like 90 different agent architecture you could play with. And so there's quite a bit of action in that domain as well. Yeah. Excellent. Any more questions? Let's see here what the chat is saying.
That's all the questions.
Perfect. So in that case, everyone, we will keep it at that. Again, thank you all for your attention today. And hopefully we'll see you in the forthcoming days in some of the other workshops. Otherwise, hopefully we'll see you later and hopefully we'll get to hear some of the music you'll do with or without MIDI-GPT. Thanks a lot. Cheers. Bye, everyone.